DoD mandate stated that all N items of value greater than $5,000 must be marked with an IUID mark by 2012. It could be an electronic assembly, it could be a pump on a ship, it could be an electric motor in an aircraft, but anything that has value delivered as an end item and has value greater than $5,000 must be marked. The OSD commissioned this group to look at this problem of legacy parts and how we're going to manage this IUID thing.
The Joint Logistics Board chartered the IUID task force to estimate how much IUID could save the Department of Defense. The task force came back with a $3 to $5 billion reduction in total ownership costs for those items that we want to intensively manage over their life cycle.
Engineering effort that's required to update the technical information on those parts. It's well over $1 billion problem in non-recurring engineering. So immediately there were efforts made to identify ways of reducing that non-recurring engineering cost.
There's somewhere between 17,000 and 150,000 individual different NSNs which require a complete planning in order to figure out how to mark those parts.
Engineers have to physically go in, physically put their hands on the current tech data packages, and they have to generate new engineering change orders, tech data packages. The drawings all have to be done manually. In the environment that we're in, where non-recurring engineering dollars are very tight, then you really need to come up with some innovative solutions to help the Department of Defense get through this period, this transition period where we have to get these items marked, we have to generate these tech data packages.
We can track, our reparable items, with a serialized number, if you will, IUID sticker, and be able to relate that back or reach back into the DoD database to gain all the financial records, where it's been, how it's been repaired. I think it's a lot better than what we're doing now. Simply, we're kind of guessing, if you will. We're trying to go back and really see, okay, where has this item been? How much money have we spent on it? Well, if we can automate that process through IUID, I think it'll benefit DoD big time, simply because right now we don't know how much stuff we have or how much money we're spending.
The CTMA program manager in the Office of the Secretary of Defense knew that there were 3 previous programs that had technology that could perhaps be brought to bear to reduce some of the costs here. Those technologies were taken, they were enhanced and improved to the point that we could use them.
We've been working on several projects with CTMA. And as part of that, I think NCMS and Greg Kilchenstein knew the technology. They asked me, can your technology potentially be applied to IUID? And I said, I don't know. I don't see why it can't. So let's give it a shot.
Those legacy parts that are where tech data exists only as a bitmap scanned image of a 2D drawing. There's no intelligence within that data. It just represents pixels. So you can't talk about engineering requirements that are captured on those drawings, which are the kinds of things that you need for product lifecycle management.
Our ability to find the shape and then extract all the relevant data is really what we do, what our technology does.
The system can recognize nameplates from a variety of sources, record the locations of the nameplates, produce a new drawing in AutoCAD format of that nameplate so that it has all of the original information plus the new IUID marking information.
Okay. So once those are defined, it'll go off and find the information in these tech data packages, fill out the forms automatically, display to the user, okay, to make sure that is all the information correct. If they're not, there's a little loop. They can go in there and correct that data if they want. Okay, and once it corrects it, it also learns. So at that point, the engineering change order is complete. It's ready to go to the to the next step.
It's simply automatically you drag and you drop the electronic versions of the tech data package into the environment, and now the tool auto-generates the engineering change orders, the drawing updates, and all the other tech data package required items that you need.
So as a side product of solving the IUID problem, we can also extract the metadata that's necessary to store these parts in a PLM system and make them searchable for future requirements and vendors and all of the things that you would like to do with PLM.
IUID will mark all of the depot reparable items so we can start tracking each of those items, then start doing something about trends rather than having to involve the marking as part of your trend analysis.
You know where this part has been used and how many hours. So as the data comes in, you can spot parts that fail earlier than they should. Maintenance problems with the aircraft, you spot those quickly and fix them. Eventually you get to the point where you're not scheduling maintenance to fix a problem, you're fixing the problem before it happens.
IUID will gain efficiencies by automating the equipment inventory at the LRS squadrons and the various organizations around the bases. We're seeing a lot of benefits because 40% of the data that you're looking at is bad data. I think that's a large amount of data. So when you start talking about IUID and how will it help the logistics community, that's one area I think that we can gain some efficiencies from. Using
this tool, this technology, we see about a $500 million to $1 billion reduction in cost.
Roughly an 85 to 95% reduction in engineering labor hours and in cost. So we're very hopeful that this will become a key method of implementing IUID throughout AFMC, and we're looking now at the ways that we could potentially use this tool as part of that implementation.
The initial demonstration was for the Air Force. There are other services. There's NAVSEA, NAVAIR, Army Ground, Army Air, the Marine Corps. The planned next step is to perform exactly the same kind of pilot for those other services to demonstrate the worth of the technology, and then to deploy it DoD-wide in a way that can be accessed by DoD entities anywhere within DoD.